Welcome everyone. The session after lunch on a Friday. My name is Nuri. I was a Microsoft Data Platform MVP. I'm also a MongoDB champion. And this talk is about MQL, the Mongo query language. But taking it from maybe a different kind of angle of looking at it from a kind of shape perspective, trying to get kind of an intuitive access to what the aggregation pipeline is doing, to help kind of get into thinking of pipelines, not in terms of just the syntax and what do I type, but in terms of what is actually happening under the scenes and what is the kind of transform that occurs from the beginning, where you run your query and documents are a certain way, to your results, which is what you are interested in getting out of Mongo. So this is kind of how this talk is structured. So we're going to talk a little bit just to get into this, just talk about the humans and patterns and stuff like that. And we're going to talk about the major pipeline operators. What are the key syntax elements that help you perform the queries. And instead of hands-on practice by your own, there will be a URL, and you can follow along, or after the conference, you can go and look at my GitHub, and there's like these exercises. I will go through them for you on your behalf or with your help, but you can do them afterwards. This is more for kind of workshop style, so you can really learn by doing. And we'll talk about performance considerations also, about what to do to optimize your queries so that they will run more efficiently, less resources. So why patterns? Why not just go into syntax? So patterns are kind of useful because we're human. And psychologically, we have this kind of behavior chain model that we operate under. It's a theory, right? It doesn't mean we work this way, but it does mean that, people in the science of psychology decided that this is a good representation of what is happening when you have a thought process. We have a trigger, something that occurs. It could be an internal or external trigger. And then we have a thought that comes into our head because of the trigger. And then we can act. And for example, if we have something like this in front of us, and that will be your trigger, what's going to happen next? Anybody? Show of hands. We kind of recognize this, right? This was here somewhere, and the next move is maybe this, winning tic-tac-toe. Or you thought another X, which also could be, but same thing. The thing is, our brain recognized the pattern and automatically knew to focus on that bottom right. How much thinking was involved in that? Not at all, right? You recognize it so well, the trigger just goes, the thought in your head is automatically doing this, and then the action is put a symbol in there. That's the winning move. So what if we took this kind of pattern matching that is built into us and try to use that, leverage it, in order to learn the syntax of the aggregation framework? We can just observe and then react automatically, not having to do so much thinking. Train ourselves to do this, and we'll be just efficient at it. So what will we observe? We observe what we have. We can observe our document structure, and the action would be to fit a pipeline to it, to figure out what the query pipeline would be based on what we just saw. So if we can learn to recognize what's going on, we can learn to compose these pipelines really easily. So observing what we have, document structures. Mongo stores documents. So when we say db.mycollection.find1, or whatever your paradigm is, then we will get a document back, probably render it like JSON. We can see that it has fields with properties, and this is the main observable thing. So it's the document structure that we're looking at. So the first pattern we recognize is a document structure that I call the flat. And the flat is characterized by having top-level fields with values. And those values are essentially non-complicated. So if you squint at it, close your eyes a bit, and look like this, and don't care about what's written in the field, it looks like this. There's the blue stuff, like the key names, and the values here in pink, kinda. And that's what the flat looks like. Just a series of colons, if I aligned all the colons together, going up and down. Key value, key value, key value, the flat. This is not a modeling class, but I would say that the flat is antithetical to what Mongo wants to be, which is a document database. Typically, I see this document structure when people just migrated a relational database into Mongo. It's not the way you want to do things in Mongo, but today we're querying, and we will encounter this. So when we encounter this, we can match the right behavior to it. The next one is the set. The set document structure is a little more complicated, but not by much. We can see ID and name is still very flat. Likes has a set of values. It's represented in an array, and Mongo does have the possibility of treating those array elements positionally, namely that it's a sequence, not actually a set. But there are many operations, especially match, and we'll see that later, that treat the values inside the field likes just as a set of elements. So if we squint at this, what we see is that at least one of the fields in this document has this shape characteristic, which is a key with a square bracket, with a bunch of stuff, and a closing square bracket. So we're what, 5 minutes in? And you already know 2 different patterns, and you already know that you don't need to read the whole document. You don't even need to care about what the value's in it. You already recognize the structure of what's going on here. And finally, the nest. The nest document structure is characterized by more complexity, more embedded complexity. We can see, we have the ID and the name or title or whatever, but look at props there. Props is an array, and in the array there are elements, and each element in itself is a subdocument. It's a little more complicated. Has some values that are in themselves, but certainly it's not a set necessarily because these elements might be of different structure. And if you see the characters there has chapters, and chapters is in itself an array. So the first element in props is not even the same as the second element structurally. So this is nested stuff. It's more complicated. And when we squint at that, what we come up with is that the main field that tells us this is the nest is that the top-level field has interleaving square and braces opening at least twice in order to make it more complicated. Okay, that's fine. So we have these 3 major ideas. These are just ideas. These are just clues. But it will help you automatically know what your pipeline stage is going to be based on this. Speaking of pipelines, when we are talking about the aggregation framework, we build query pipelines. A query pipeline is represented by an array of major pipeline operators, and each one has its own nuances of what parameters you give it, but essentially it's passing documents from one stage to the other, and each one does its own little job. Even in pipeline sequences, we can find patterns. And the ones I look at from a 20,000-foot view is we have this gather. So the beginning of the pipeline is where I get to collect all the inputs I need. the middle, which is the main course, which is where I do all of the kung fu to shape things, to sift them, to do all of the, not sift them, to reshape them and do the operation I want to do really in processing. And then a final stage to present it. So after I did things and I had my middle pipeline stages do whatever they needed to do, I might come up with fields that, or a document structure that I don't want as a result. I want a different document structure as a result. So the rest is window dressing. The rest is really about preparing it for consumption. The major work is already behind us. So that's kind of the UI portion of the pipeline. Is it mandatory that we have all three logical pieces of a pipeline? Always. No. I can have something to say, I want to run a pipeline that just filters documents. That would be gathering the documents I want, and I don't want to do anything with them. And they're fit for consumption. It's fine. I can have something and say, okay, I want those documents, but I want just a few fields from them. I want to kind of maybe reshape the thing. I don't have a middle part. That's fine. I can have something, wouldn't recommend it, I can have something where instead of gathering just the documents I want or just the materials I need for assembling, I immediately jump into assembly. That happens when I do like geoqueries or when I do want to do an aggregation on the whole input collection and not just on select documents. Hopefully that's rare. So the gather stage is characterized by operators that are focused on getting the materials we need, rejecting the materials we don't need. So what do we have in there? We have finding documents, which includes filtering, putting them in a specific order if order matters. Typically operates on a single collection. I know MongoDB has $lookup. Please use it mostly never. Use it when absolutely necessary, but consider remodeling your document structure so you don't need it much. So typically one collection, and sometimes multiple collection, but hopefully that's rare to get the information necessary to process the rest of the query. And its main function is to liberate data. Basically, the data was stuck on disk. You bring it in and you pluck the things that you need. So you might also at this point reshape slightly, decompose complicated fields, recompose things that were separate and want to be together. Maybe you had a price and a quantity and you wanted to multiply them in order for the rest of the stages not to have to do it, but you do it one document at a time, so it's still gathering. And finally, plastering over or fixing document structure where your underlying fields were not how you like to see them, so you might need to do this in your gathering stage to convert dates that were strings into proper dates, or to do things of that nature where things were null and you need to give it some kind of symbolic name so that it won't throw exceptions later in your pipeline. The assemble stage looks to do the actual work, and it boils down typically to group by. Because the only reason I'm using MQL and not just using a straight find or a straight sort on the whole collection is because I want to do something that crosses document boundary. I can do a find, I can load items and process them in the application, but that would be inefficient. But if I want to do some sales by month, I need a group by. And typically, reports have a group by. If you don't have a group by, there's very little pipelining you'll do except for geo restrictions or things like that where it's really just a find. And finally, the fit and finish, making it useful for consumption for your application, will be to get rid of fields you don't need, to rename fields so that they're readable how you want them, to limit a result Maybe you don't want all million documents, you just want the first 10, the first 100, skip a few and take the next batch, paging through things, all of those are kind of fit and finish. They do not typically do anything that, not typically, they do not do any modification cross-document, they just kind of shape the results, shape the final result. And there's also the variant where you can use MQL and as your final stage, say $merge, and put the results into a collection instead of returning it to the client. That is also, in my definition, fit and finish. So what are the major operators? There's some 30 operators these days with pipelines. They added a lot. There's the most recent ones with version 5 and 6 are the time windowing stuff for reporting, mostly analytics. But there's new operators with every release. These are kind of the major ones I see very commonly used, so I listed them. $match is a filter. $match does which document do I want, bring it. The ones I don't want, don't let them through. Group is the group by, as I said, usually the bread and butter or the meat and potatoes, the main part of the course of processing in the middle there. Sort for fit and finish typically, but could be for teeing up things, puts things in order. Project, picking a few fields out of the document, changing their name, doing light calculation of two fields within the same document. Project works on one document at a time, so that's how it works. Unwind, exclusively used for array unwinding, and we'll see that in a demo. Lookup and graph lookup, used too much to my taste. Graph lookup is useful if you want to use MongoDB as a graph database or to represent a graph structure. But I don't know that you would do a full algorithm for like Dijkstra, kind of minimal path and all of those math kind of things. You'll use it for light hierarchy, like who's the boss, who's the worker, who's the boss's worker, whatever. Things like that. So graph lookup, it's much less efficient to do this client side, but still I would say model your document such that you don't need to use too much of graph lookup or lookup. $out and merge are, out was a predecessor to merge. Merge is the preferred one these days. It allows you much more flexibility to store the results into Mongo itself, into a collection. And then add fields is kind of syntactic sugar, helping you do things that project could. So those are pretty common. Also, I would say facet is becoming a little more common these days. Then other stages, still good to know here, facets here. Bucket, auto bucket, things like when you do searches and you want your products by size, by prices, things like that. So bucketing the results, kind of similar to what group would be using. It's syntactic sugar that helps you do this more efficiently. $count, limit, and skip are the ones used for paging. When you have large result sets, you don't want to return them all at once. Redact, I haven't seen really in the wild. It's been around for a while, but it allows you to pass along to the next stage just fields that are certain nestedness inside. So if you have some public information and in it some field that has more private information and more, you can redact things and say I only want level 1 fields or level 2, up to level 2 fields or up to level 3 fields. I suppose if you're running a secret organization, that's helpful. Replace root is some mechanics that have to do with how you process the document within a stage. Sample is very useful for ML, for machine learning. Sample is allows you to do efficient selection of data from a large collection in a stable way so that it is statistically significant according to the density you give it. Anyway, this is a general intro. And what I'm going to do now is switch to demoing, and we'll go through some katas, up to 5 katas, Let me also give this link so you can do it at home or follow along with me or whatever works for you. I put in the room 1 Slack, I put the link also, so if you want to grab it on your own device later, or the QR code. So in the next time we have left, and also open to questions, we'll just go through a few of the exercises looking at source documents, determining the pattern of their structure, matching them to a major operator, and like trying to use it. So the first one is the kata is called pass or not. It looks to use matching, basically using $match to filter documents, limit, sort, and skip, which together are a pattern of paging that you always see them together. Remember always to use sort when you're doing paging, because if you come back for the next batch and things change, you want a stable basis for your sorting. So if somebody added another item, you don't want to miss it, or a previous item, you don't want to show it again. So those are important combinations. Let's look a little at the syntax of it. The syntax of match on the first line here. Match takes a field name and a value. So at our simplest form, a match would take a field name city here and say all documents that have a city field with a value of Kent, exactly verbatim, capital K-E-N-T, I want them back. If a document doesn't have that, it won't. If a document doesn't have city field at all, it won't come back. So this is fairly straightforward. Because matches sometimes do ranges, so you can do $GTE or $LT. There's variations that you can do range, matching, and logical operators, but this is kind of the simplest form. Sort takes a field. In our case, it's sorting on the underscore ID field and gives it a direction. The direction is determined by a number. You can say -1, that's descending, highest first, lowest later, and a direction of 1 without the negative sign would be ascending, smallest first, largest last. What is smallest? If it's a number or numeric, it would be compared numerically. If it's a string, it would be lexicographic, meaning B following A, C following B, and so forth. And if it's a number that's quoted in string, it will be lexicographic, unless you can do in Mongo, you can give it a collation, and you can set a collation order that coerces strings to be numbers and interpreted as their numeric value. Otherwise, quoted strings are just compared lexicographically. Skip just takes a number, says how many to skip. So if you say skip 1, the second document coming through and on would be allowed. The first one would be ignored, drop to the floor, never come out of the pipeline stage. And aggregate takes a limit, and limit takes a number, and both these numbers for skip and limit are just what they are. So don't think array offsets, think just the number. So limit to 2 means 2 will come out. Skip 1 means the first one that comes in, ignore it. Okay. So with that, let me see if I can switch screens here. Can I share this? So this is the first kata, and I will go to this playground in a second. It says basically inspect the data set to look at the document and try to figure out what kind of document it is. the flat, the set, the nest. And then create a pipeline to return everything for people who live in Jackson. We'll look at the set in a second. And then return all documents in order by city name ascending, then by person name descending. And from this list, return the second person only. So we'll keep this in mind, not try to memorize it. I'll jump here to the Mongo playground. And we have a collection here. Let's look at it. Each document is here. There's a underscore ID of the document is the name of the person. And the city has the city name. So what kind of document is this? Flat, nest, set. Flat, that's correct. It's flat because it just has top-level field with a simple scalar value. Nothing fancy, no set of things, nothing embedded, certainly no interleaving of braces and square brackets. It's just flat. Okay. So with flat things, we can directly access them with $match. The first thing I want to do is I want to say, let me get the people whose city is Jackson. In order to do filtering, I need to do a filter expression. So this is a $match. And here we go. So the first element, I have a flat document. I just put the name of the field, put a match operator. That's a way to sift through, to reduce. And of my pipeline stages, this is the gather stage. I'm just gathering information. Gathering means take the stuff you want, drop the things you don't. Second item in the Kata tells me, okay, well, I returned everything, all the fields, right? I didn't try to manipulate the document. I just decided return or not, as is, verbatim. So now bring him in order by city name first, and then by person name. So this is not Jackson anymore. I want all documents, right? All documents. Oops. First by city name, and then by person name, descending. Okay? I'll go here. I will remove this match because I'm no longer gathering. I'm actually doing just one thing. I'm doing fit and finish. I want to prepare all documents for human consumption without any grouping or anything fancy. So what stage, pipeline stage I need first? I need to put them in order, so that would be sort. And for the sort specification, I want them by city first. And I want it ascending or descending. Ascending city, descending name. So ascending city is 1 for ascending, and then descending name. The name happens to be in the ID field, and I'll do descending. And I can see that it's Boulder with a B, J, Jackson, and then Kent, JK. So this is an alphabetical order. But within Jackson, I get Dan and Jan. Jan is J, bigger than D for Dan. Now, some of you may come from programming language where keys in a hash or in a dictionary are not guaranteed order. In our case here in Mongo, Mongo has this notion of the key order. So yes, it does matter that I said first by city, then by ID. If I flip the order of these, it matters. Well, in this case, would it in this case? No, it's still that, but the order is preserved, is the point. In the pipeline operation expression. Okay, so this is pretty simple. I did a gather just by using match. I did a fit and finish by using sort. ascending, descending. Pretty easy syntax, nothing too difficult. But then the last thing is I want to get only the second person. So if I want only the second person, what do I need to add here? What pipeline stages? Skip and limit. So the first thing, for the second one, I need to skip the first one, right? So I will put a $skip value, skip 1 exactly. And then I only want the second one, so after I skipped one, I'll limit my result set to 1. And lo and behold, I sorted them. I took, I can do this to convince ourselves that it's correct. I skipped Kim, and I took Jan, and that's that. So that was correct. All right? So 5 minutes, match, skip, limit, sort. And when you see a flat document, you can just put the field name in. I think we have in the next kata where even we can reach into embedded documents. So if you have a thought on that, just hold on 1 sec, we'll get to it. So before we move to kata 2, let's take a look at the main idea here. Main idea with kata 2 is to use grouping to batch up stuff. And we'll talk about the group. It's $group is the main workhorse of the aggregation pipeline. Most of the aggregations you'll write will contain a group. Otherwise, you could just use find. So the way group syntax works is group, there's the name of the operator, $group, and then you have to give it an ID. Because group, just like SQL group by, you have to say group by what. And that what is the underscore ID. It's a fixed name, just like every document has an ID. Every group expression has to have an ID, and the ID is what things are grouped by, what things are batched by. And somebody's thinking, wait, but what if I have to group by 2 fields, year and month? Okay, well, the value you're grouping by could be 2 fields. It could be complex, but it's still going to be named ID. So at the top, we have a group by expression that has $ALL. Yeah, it's the word all, but it doesn't mean anything. It doesn't mean alles. It's just a constant. You could group by any constant, a number, a string, doesn't matter. If you do that, you're essentially saying, create me one group, because this value, ALL, is just one group. So then any aggregation I will do, whether I count, I add by using sum, I do averages, I do whatever, all of that will be just one group produced. If I want to group by one of the fields, I use the value of type syntax. And we see it here. And what this does is, instead of having just the name of the field name, like for first name or something like that, right? So instead of grouping by the constant name, I'm grouping by the value of the field name. At which point some of us are saying, wait, headache, I have a $sign. It means value of field, but Mongo also interprets $sign to be the name of the stage or the name of the operator, right? $group. So why isn't $group the name of the field group? Well, dollar to the right of a colon means value of, and dollar to the left of a colon will mean an operator. So $group is to the left of the colon. That means it's the name of a pipeline operator. $count or $AVG on line 3 here, from the on last line in the slide here, $AVG is to the left, which means it's the average operator. And $score is to the right, which means it's value of field. And we put quotes around anything to the right so that JavaScript doesn't get utterly confused. So that's what that is. All right? So group by, we give it an ID, and then we give it a group by operator, what to do. And in our case, on line 3 from the top, n colon $count of everything, basically empty squiggly braces, count the stuff. It says, I'm going to count items within the group. Which group? The group of all documents. Okay, so it's just going to create one group and a count of how many documents in the collection. The second expression says, oh, I'm going to group by the value of the name. So for each name, there's going to be a group. And what do I want to do? I want to average the scores by name. I want the $average, AVG, of the value of score. All right? So let's see it in a Kata in action. $count lets you count stuff. $sum lets you add things up. And AVG lets you do the average. There's other things, stdevp and standard deviation and stuff like that. You can do other aggregation. We're not going to cover all of them today. Let's see here. I'm going to switch to Kata 2 here. So I'm going to open up this document here, this area, and we can look at the documents. The documents are the score document. This syntax here of DT is a $date of this. This is extended JSON just to tell Mongo that this is an actual date, not a string. So it's just a way to represent it in JSON so that we don't have to look at epoch numbers and things like that. But otherwise, this document is flat, right? Just fields. So there's a ID of the score. It's a numeric ID, meaningless. There's a name for who scored. There's a subject, which is what class they took. And there's the date of the exam and the score they received. So let's look at the Kata here. So we looked at the stuff. And then create a MQL pipeline to return the average score across all students and all subjects. So in our gather stage, are we putting any matches? No. We're jumping right into group because we want everything from the collection. And we want the average. Okay? So the first thing we do is, being that we want across everyone, $group. And the ID is anything really. So I'll put NDC 2023. And then the field, what did we say? We want the average. I'll call it A. Average stuff. Doesn't matter what I call it. $AVG is the operator, average. And what do I want to average? I want to average the value of $score field. And here we go. Because I gave group an ID that is a constant, it aggregated across all documents. And the operator is average, so it did an average of all values in the score fields. Fair enough? And then return the maximum score by subject. So now I want to bucket by subjects. So instead of a constant here, I'll have this be the subject, value of the subject. And the operator I want for the name of stuff, let's say maximum is my field name. I can name it whatever I want here. Maximum ... It's just a string. Mongo doesn't care. and I want to use the max operator, which is one of the aggregation pipeline, and that will be the maximum score. Any field except for dots, because that would be dotted notation. So let's not be too cheeky. So now I got back the result saying, here's a maximum field by value, by subject. And this is the ID. Because I extracted, the grouping goes into ID. It says ID is art, ID is math. That's not fit and finish. I can add a stage to rename that if I want. All right. Let's see. We got another 15 minutes. Yeah, we can go through a couple more, and then we'll maybe talk about performance and open to questions. I can push through. I just want to be respectful of our time here. Any questions on group? As I said, group is the main workhorse of aggregations and reporting in Mongo. You will be using it a lot. Get comfortable with it. So the next thing is unwind. Because Mongo is a document model, and because we will be doing things like multiple things within a document, like I have maybe I have an invoice, and I have the customer once, and I have the total price once, but then I have as many items and they put in the cart with their quantities and individual price. So it will be a complicated document, right? There's going to be a set of items attached to this invoice. So this is where unwind comes in, because the way pipelines work, pipeline operators work, is they see each document coming in and process it once. Well, if I process it once, but I have many things in it, I don't have a way to loop through them. But if I put a stage before that, that unwinds these arrays of items and feeds them as a single document into the next stage, then I can do something with them. And this is when unwind comes through. Unwind, invariably, you give it a name of an array within the input document. And we're interested in the value in the array, so it's a dollar value of. Dollar colors is a field in the document that enters there. So the operators unwind, you give it a field name, and what it does is for each element in the array of the input document, it outputs the whole document with only a single element. So I have a document with colors, red, green in an array, and I unwind the colors, and it would come out as the document with red, another document with just green. So now instead of having an array, I have a single element in that field. And now I can process them. There's nuances to unwind. You can tell it to also emit the sequence number of the element in the array. So that's an option. It's optional. You don't always use it. Include array index and give it the name of the field you want the array index in. And you can also say, if there are null or empty arrays, should I output the document at all? In which case it would have a null or no value in that field, or should I suppress it? Because documents are flexible and sometimes you don't even have that field at all, what should the operator do? So these are nuances and options you might need. Let's take a look at an example here for this. Let's see. Blah, blah, blah. Let's go to our trusty repo, Kata 3. Here's our document. Brands. Each brand document is like this. What kind of pattern do we see immediately? I hear set. Anybody else? Yeah. So this is a set. We have an array here. We don't have more interleaving. The elements in it are considered a set. Colors is a set. So with this set, we want to create a pipeline that returns the document ID in a single color from colors. So my requirement is simply to take this stuff, and for every document, just return the ID and a single color. Well, that's pretty much what Unwind does. So I want to unwind the field value of colors. And when I do this, from this brand A, you will see that there are brand A emits 3 documents, one with green, one with blue, one with gray. Green, blue, gray. Brand B has only 2 elements, so I will get 2 brand B documents, a purple and a blue. Fair? And similar to this, I can add an index by using the, add index and give it a name. This is just an exercise you can take home. It's extra options, but the main thing to remember about Unwind is it parrots, it echoes all the original fields plus exactly 1 element. You'll also notice that before, this shape was an array, and now this shape is a scalar. Now, if that value had like a complex object, it will be that complex object, but it's no longer an array of things. It's not an array with a single element. It's just this 1 element. So that's that. Let's see. We're kind of going to run against time. So let me get back to a little syntax, and then we'll talk about efficiency. When we talk about isolation, taking fields out of where they were, we're really talking about the gather stage, where we want to take elements, but something was bigger or not exactly what we want. And the operator, why am I here? Sorry, that will come next. So this one is about isolation of individual items by digging into complex items. Like, let's say I have an address, and address has a city, line 1, line 2, country, blah, blah, blah. This is still considered flat. Why? Because it's not complex and it's not a set. City and country are 2 different fields. Yeah, structurally in JSON they look like they're embedded, but effectively it's just a path to a single scalar. There's no order to it. There's no multitude of it. So the way to do it with Mongo is just to use the dot notation. So I can match, just like I did before, but instead of matching the whole address, just match one of the fields within address, in our case, city. And this can be used in a match. It could be used in a sort. It could be used in an aggregate. The field itself, dot notation, lets me dig into a subdocument, and I just put the period there, which is why when I did something silly before and I put dot, dot, dot in the name, it's like, whoa, that means something special. It's dot notation. Don't do that. So that's that. I don't think this requires a big demo, but you can practice it at home. The next thing is project. And now I don't want to just look at the sort stuff. Project can be used to tee up things for the processing, could be used for beautifying, as my last fit and finish. So the way project works is it's a field selector, right? When you say select field 1, field 2, field 3 from blah, blah, blah in SQL, project is kind of similar to that. It says, well, let me look at certain fields within the document and only pass them along. Now, project is actually 3 operators in a trench coat pretending to be one. First, it has a blacklist, whitelist behavior, which is to say, project can say field name 1 or field name 0. Field name 1 means whitelist. You can say, I want just field 1, 2, 3, 4, whatever. Sorry, I just want field 1 and field 2 and stuff like that. And if you do that, then the rest of the field you haven't mentioned won't come back. So it's kind of like a nightclub bouncer. Everybody who has the little pass, they can come, they have a little 1. If you don't have the pass, you're not going to be emitted on the other side. It also has the behavior of blacklist, which is field name and a 0. And in that case, if the field is mentioned, it will be suppressed. And all fields you want to suppress, you have to put. Anything that hasn't been suppressed will be passed along. And then the third one is to say, well, I don't want to do blacklist, whitelist. What I want to do is create a new field altogether, the way I want it, and assign it values, either by doing light math or just taking the original value. It's confusing, but what it says is, like, I had a field ID coming into project. I don't want the field ID. I want it to be called first name. Okay, then project can just say project a quote-unquote first name, $value of _ID. And that way, it will rename essentially a field. And you can create structured values or whatever. So at the top, what we see is a project that suppresses the ID, says don't give me back the ID, and do give me the date, the DT field. And the bottom expression says, I want to calculate a new field I call boost, call it NDC, doesn't matter. So I want a new field named boost. You see it doesn't have a dollar in front of it, so it's not an operator. And then I want the value of boost to be the result of multiplying the value of the field score, quote $value of field, comma, by 1.1. So multiply is one of these operators that's commutative, transitive. You can give it as many elements as you want. Divide is not as tolerant. You have to have numerator, denominator. Add, you can have a $add with many items. So you can do light math, assign it, and project will do it. All of the changes project does, it does to one document at a time. So if you pass 1 million documents, it won't emit just one document with everything. That's group. Project will just slice fields out, produce new fields, and pass it along. And finally, we put bigger pipelines together. I spoke about pipelines, but I only showed you essentially one at a time with the exception of skip, match, sort. They're meant to be composed. And that also means that our big pipeline thing of like gather, process, finish, that can be repeating. And it could be recursive, that within a finish, I still want to gather some stuff and I still want to do things. It's a pipeline. You can stuff it with however many operations you need to. So here, we may match on the color blue. So the items had an array, and in it there was blue. So if the array had blue, then it will pass match. Doesn't matter where blue was in that, because it's the set. It says, hey, does the color, the set of colors, have blue in it? If it does, it will be matched. Unwind the colors. Okay, take that array that had blue and unwind it, and now I'll have each color on its own. That means that I have blue colors, but also red colors if they were in the original array. I didn't really filter red out. I just said, hey, does the document have blue at all? So I unwound them. I then grouped by color and counted them. Sum of 1 is the same as counting. And then I sorted it. And then I only took the top color across all documents. So effectively, the match of color just said, do this, but only to documents that originally had blue. That's what it is. So it takes a little more time to get used to this, but with this thinking of what's the pattern? Okay, it's a set, let me unwind it. I want to process it, let me use group. I want to limit which ones I look at. Use, match, skip, sort. And finally, fit and finish. Output it in the way you want. Maybe project the fields you want, things like that. So where do we optimize things? In the gather stage, because gather is going to look at the original collection, we want it to be index assisted. And if it's index assisted, we really want to make sure that the fields I'm matching on are indexed. Simple enough. Not only that, omitting the gather altogether and skipping into assemble means I process the whole collection. That is a full collection scan, same as full table scan in relational databases, a lot of I/O. In cloud parlance, it's a lot of scanning, it's a lot of cost. So don't do that. Always do a gather. Always do a subset of all your documents, because indexes can help performance, and without it, your performance will suffer. If you're doing a full collection scan in Mongo, even if things are in memory, it's not going to be too fast. You always want to be index assisted. In the assemble stage, there's not too much to optimize. In assemble stage is where what our optimization will really be about reducing the amount of fields we work with. So you might use some projects in order to reduce the size of document. You might make your pipeline go through less data in any kind. We're doing secondary matches or unwinding and then filtering the colors you didn't want again, things like that, to just reduce the size of things. Group and sort are two pipeline operators that need to see all documents coming in before they can emit the first one. How can I tell you which is the biggest if I didn't see all of them yet? How can I tell you how many sales in January before I saw all sales for the whole year and determine if they're January? I can't. Because of those are greedy operators, and they will ramp up memory. And if Mongo sees that they use more than 100 megs, it will shut down the pipeline and produce an error. Now you can tell Mongo, hey, it's okay to do swap to disk, and it won't shut you down, but it will slow you down. So that's a good reason to use gather and reduce the size of the documents getting into group, potentially by trimming away fields that group isn't operating on. And that will reduce the memory footprint of the group. And finally, in present, not a lot of optimization opportunities. There is merge, which changes how you build pipelines, because merge is smart enough to say, if I want cumulative sales over the month, I can calculate them nightly and just add them to the current month, rather than calculate all sales from the beginning of time and replace everything in the collection. You can do cumulative stuff. So this is where in present you kind of think, okay, if I really need to do things a little more efficiently, I can do maybe incremental stuff. Sorting is expensive. If you need sorting, do it. If you don't need Mongo to sort for you, or if you're going to sort on the UI anyway, don't sort here. And the other thing is in present is, if you don't want to return everything to the client, if they only need 10 to show on the page, use skip and limit. And that would make things more efficient, because Mongo can be done with a job after shipping 10 instead of shipping all million documents from the disk. So this is the optimizations around present. And with that, I think we are 1 minute over. But I'm open to questions if anybody has them. Any questions? Everything good? All right, thank you very much.